Hi, my name is Dr. Forrest Blake-Ambridge. I'm a chiropractic neurologist and functional endocrinologist. It's my privilege to be able to introduce a presentation that was offered March 18th with Dr. Ari Vojdani. He is a renowned, world-renowned immunologist who has developed a number of tests which are highly sensitive and specific for autoimmune issues and environmental factors which challenge our healthcare. So we held that on the 18th at Medtronic, and we had about 75 attendees with about 25 different practitioners. So it was a great evening. I just want to let you know that this was on our YouTube page so that people can view this. I pursue this and utilize this in my practice as an endocrinologist and neurologist as a result of people's failing systems. So I see their systems not working well, and so it's brought me to have to address other kinds of conditions that affect brain and other parts of central nervous system. So I hope you enjoy the presentation.
Thank you, Dr. Ambridge. I was supposed to be here almost a year ago. So we're talking and talking and talking. Finally, I'm here. And thank you for your hospitality and kindness. I'm so happy to see so many people in here. So I'm going to share with you almost 50 years of experience working in a clinical laboratory since I went to university, started with biochemistry, microbiology, then immunology, and then clinical immunology, and I've been there, in that field forever. So today I'm going to talk about how environmental factors can have an impact on autoimmune disorders. So today, here I have for you a very simple message to take home with you. And that message is actually, first, you have to be able to detect exactly what the clinicians are doing. You have to have a reliable test to detect any abnormalities in our system. If there is no reliable test, then you are going the wrong route, probably. So therefore, the detect is very, very important. When you detect, then you have to find what are the environmental triggers. Is it infection? Is it the dietary components? Gluten is not the only one. Dairy is not the only one. Maybe in your patients, some of your patient is egg, or another patient is corn. So you have to look at the whole picture of dietary components. In fact, now we know that significant amount of salt in the diet can activate certain cells in the immune system, which makes them more pathogenic to attack our tissue and cause autoimmunity. So who knew up to 3 years ago about the role that salts can play in autoimmune disorders? So we have to look at the whole picture. Dietary components. Okay, it's not gluten by itself, it's not milk by itself, it's the whole components of diet. And finally, toxic chemicals. So we have to detect. When you detect correctly, you remove them from the environment of the patient. And believe me, you are going to make a huge difference by repairing whatever the abnormalities are. If it's the gut or blood-brain barriers, if you do repair and prevent entry of all these environmental factors into the body, you are going to make a huge difference in the life of your patient. So this is really the summary of today. So remember, DRR, detect, remove, and repair. So with that introduction, let's continue. According to American Autoimmune Disease Association, 53 million Americans are suffering from autoimmune diseases. About 10% of the world population is suffering from autoimmune disorders. I'm not going to read all of that. Some of the examples are here, multiple sclerosis and so forth. And unfortunately, when it comes to the male and female, the ratio is much higher in females than men. There are examples of some disorders, for example, whether rheumatoid arthritis or other disorders, could be a ratio of 17 to 1, female versus male. So therefore, that's why, you know, over there, that I'm showing you that there is more autoimmunity in the female, and ask yourself why. I have a presentation just about that. There are hormone receptors on lymphocytes, for example, can activate the lymphocytes, and those lymphocytes releasing antibodies and can attack the tissue. That's just one example. So now let's look at cancer. 1 in 33, 70 million cost. Autoimmune, 1 in 6, 120 billion. And the main reason is really because my own mother suffered from osteoarthritis. And she passed away after 40 years of suffering, believe me. Total knee replacement and all that sufferings were for many, many, many years. And so, because patients with autoimmune disease, they don't die, they suffer for many years. And so anything you clinicians can do, help to alleviate their suffering, is really greatly appreciated. Now, let's look at research. These are all, you know, based on National Institute of Health. Okay, we spend $6.5 billion in cancer research every year. Heart disease and stroke, 2.5. Autoimmune diseases, remember, 1 in 6. But we spend only $600 million on autoimmune diseases. So if you have an autoimmune disease, you have to take care of yourself. Or you have to find good clinicians, like some of those who are sitting in here, to take care of you. So autoimmune diseases can take many forms, attacking tissues in different parts of the body. Okay? Neuronal tissue, skin, internal organs, and this is my mother's hand. Okay? So you could see the suffering in there. She passed away about 10 years ago. So any part of the body could be attacked by our immune cells and causing autoimmunity in that area. Is it the gene or the environment? What do you think?
Both.
Thank you. Is it 50-50? Okay, so the answer is in here. This is again National Institute of Health, one of the best research centers in the world, which is in Maryland. And I had the honor to spend some time at National Institute of Health many years ago. And so the bottom line, what they tell us in here, they looked at identical twins. Some of them 15 during their lifetime, some of them that had a 15% chance of developing autoimmune disease, some kind of autoimmune disease. The other 50%, the other 85% or 50% never developed autoimmune disease. So they came up with this number. 1/3 is genetic, it's right here. The other 2/3 is environmental triggers, environmental factors. So remember, regarding the genetics, can we do something about it? Can we change our genes? Everything is imprinted within our DNA. We can't do anything about that. But the good news is, yes, we can do something about the other 70% by looking at the environmental triggers. So this is a good summary now. So genes plus environmental factors, dietary components, toxic chemicals, and infection equals to autoimmune disease. So in genetic susceptible individual, those 3 factors play significant role in the development of autoimmune diseases, but not necessarily you have to have just the genetic makeup. And many other individuals may not have genetic makeup, but they will be exposed to many toxic chemicals, definitely will develop some type of autoimmune disease. So So that's why I'm putting so much emphasis on the issue. We call this now exposome. You know, omed is after every word. That's the modern way of looking at different scientific expressions. Exposome goes to microbiome. What is that? Microbiome, the bacteria within in the gut. That goes to, you know, the genome. That can affect our genome, can affect our proteome, metabolome, immunome, and autoimmunome. So all that is connected to each other. So from exposome all the way to autoimmunome. So now, in addition to those three environmental factors, in some articles by very famous gastroenterologists in the world, who published articles in the field, they add the fourth component saying that gut bacteria play, in addition to infection, toxic chemicals, and dietary components, the gut barriers and bacteria in the gut playing a role in autoimmune diseases. But, you know, for me, we know that these bacteria also get affected by those three environmental factors. So I don't need to put this as a separate category. It's already part of that. So therefore, let's talk about, you know, commensal bacteria, which every month, which I read about 30 different journals I get every month, there are 20 to 30 different manuscripts in association or about the role of good or bad bacteria playing in health and diseases, in particular autoimmune diseases. And so therefore we have to know about the intestinal microbiota, how much can contribute to health and diseases in the gut and beyond. And you will see the evidence. And so here we know that commensal bacteria aid in digestion, supply nutrients such as vitamins, and prevent pathogenic infection, maintain our barrier defense, which is extremely important. That's a gateway to autoimmunity. Maturation of the immune system, in particular IgF production, which is part of the gut mucosal immune system. Maturation of regulatory T cells in the intestine. There is a cell in our body called Tregs cells. You know, we have in the immune system, when a child is born, is in a state of imbalance like this, the first day. As soon as the child gets exposed to bacteria from the hospital's environment, and mother's skin, the vaginal canal, all of that together will start helping the immune system to become balanced, which will take about 6 months to a year. And so therefore, to do that, we need these cells, Treg cells, regulating the immune system. The imbalanced immune system becomes a balanced immune system. So those Treg cells may be in the tissue of the baby, but they are not active enough. They become activated, and then they bring the immune system to a balanced state. And now, how about a child which is not breastfed, or they don't go through natural birth, they don't get the lactobacilli from the vaginal tissue? They will stay almost, you know, for the rest of their life in this situation. Therefore, they develop allergy such as peanuts allergy and other allergies that you heard about. So that's why this cell is so important, and maturation of that cell depends on the gut bacteria. Enhancement of immune function, natural killer cells. What are natural killer cells? It's a type of cells which are fighting against viruses and cancer cells. You know, when it comes to winter, everybody talks about flu season. Let's have our flu vaccine. For me, the best flu vaccine is to enhance my natural killer cell activity, because that is going to protect me against every kind of viruses, including those who may cause common cold. And so therefore, the enhancement of natural killer cell by probiotics and good bacteria is extremely important. But at the same time, if there is imbalanced gut flora, can cause also disease such as inflammatory bowel disease. And also influence beyond intestinal tract. You will see some slides about this. That infection in the gut can cause neuroimmune disorder. And then correction of autoimmune bias in females by bacterial transplant. I'm not calling that anymore fecal transplant. Bacterial transplant. It sounds much better, right? So there are many, many examples in Science and other journals that I read. For example, if one of the couples is obese and the other one is fit, you do transfer of fecal bacteria, and then after 6 months or a year, you'll see that individual is going to lose weight. What happened? This is proven already. Some gastroenterologists are doing that. And in here, if someone has autoimmune, by changing the bacteria, first they give antibiotic, destroying the bacteria completely, and then they transplant a new bacteria, and then as that bacteria grows, releases good factors which can prevent autoimmune disease. So really the message up to this point is this, that take care of your gut as much as you can, support your gut with good bacteria such as probiotic, not with yogurt, with probiotic. All right, so you are with me so far. Okay, great. And also you can see that involved in liver disorders, arthritis, and polyglandular syndrome, and many other autoimmune disorders. So we have to take care of these good bacteria for overall health of yourself and your patients. So we know that all these three factors can affect the gut microbiome. And you'll see examples that if you have infection with Porphyromonas gingivalis, that bacteria can release a toxin. The toxin goes down there and changing the integrity of gut microbiota, right? And then that can result in dysbiosis. The results of that could be all one or all of this. Asthma, allergy, and autoimmune disease, metabolic syndrome, and so forth. But we have to have our patients in state of eubiosis, not dysbiosis. Balanced gut microflora. And immune homeostasis, healthy and stable state. What happens when we have abnormal gut flora? Abnormal gut flora release toxins such as endotoxins called lipopolysaccharides, LPS. Unfortunately, those toxins from bacteria can break the tight junctions. Breakdown in tight junctions causes entry of unwanted bacterial toxins, undigested proteins and peptides to the submucosa and finally into circulation. What happens in circulation? The immune system will react. We make antibody against that. At the same time, all those factors in circulation causing release of pro-inflammatory cytokines. So those toxins plus these cytokines now can open the blood-brain barrier. The inflammation from the circulation now goes to where? To the brain. That's why we have to pay attention to the gut, even if you have a patient with multiple sclerosis. This is the mechanism of action. If we don't repair and these toxins will enter all the time into circulation, this cascade will continue and the attack on the neuronal cell tissues will continue, and we'll lose our nerve, the number of nerve cells, and the results of that could be at certain level MS-like syndrome. So therefore, even for autoimmune diseases, we have to repair the gut barriers, then the blood-brain barriers. And there are ways that we are going to discuss them. Now, by the way, I'm really from each, I can speak for 5 days. I have so many slides. So I have chosen from each part of my talks 1 or 2 slides. And these are all evidence-based science. For example, this individual, I call it Dr. B. Okay? From, in the Journal of Gastroenterology. Did very elegant experiment. He took mice, and mice, some of them are shy like me. Right? Yeah, for example, this bulb-C mice, they're timid behavior, and NIH mice are courageous and they like to play playful and all of that. So this elegant experiment, he took the babies of this mouse and the babies of this mouse. On the first day of birth, which are called germ-free, they're free of any bacteria in the gut, they transferred to bulb-C the bacteria from NIH mouse, and to the NIH mouse, they transferred bulb-C bacteria. What happened? Their behavior switched completely, right? And I have another 20, 30 slides about this issue. So the addition of different bacterial strains can change behavior. That's very well established in the scientific literature. Now, another slide which is very important, just look at the title at the top. The gut-brain barrier in major depression. So that's the connection between the gut versus brain. Intestinal mucosal dysfunction will increase translocation, remember the endotoxin lipopolysaccharides, from gram-negative enterobacteria such as E. coli, Salmonella, Shigella, those some of those who cause, for example, food poisoning, plays a role in the inflammatory pathophysiology of depression. So if you have a patient with depression, you wonder how come when you give them EPA, DHA, their depression improves. Maybe you are doing something about this, bacteria. You are repairing probably a little bit the gut by giving them EPA, DHA, fish oil, and therefore you are preventing depression. And also, they talk about measuring antibodies against lipopolysaccharide as a biomarker for detection of leaky gut. And so, Dr. Amber introduced me being as a chief scientific advisor to Cyrex. How do we develop testing? It's not at night we sleep and in the morning we come out with these ideas. We read about it, right? We read about, we take that, plus experience which we have, in my case, 45, 50 years, put it together, and then you come out with a test. And so one of those tests which I would like to share with you, later on you will see is that. So now, back to the gut bacteria, that overgrowth of pathogens during, in the gut, during pathological inflammation, there is a kind of new bacteria just a few years ago, about 7, 8 years ago, discovered, called segmented filamentous bacteria. Segmented looks like worms, like that. So those were like spirochetes. Like Lyme disease, they look exactly the same. So what will happen in the gut? You remember that Treg is so important? The Th1 and Treg cells are very important to regulate the immune system. But these bacteria activating a pathogenic lymphocytes called T helper 17s, the same one which is get activated by salt in the gut. When those T helper 17s become activated, they migrate to the submucosa and into the circulation, and then activate T cells and B cells to produce antibodies against different components of the body, in this case, antibodies against the joints. And T helper 17s can migrate to spleen and other part of the body cause autoimmunity, can even migrate to the brain by going through blood-brain barriers. They have a mechanism to break down the blood-brain barriers when they are in the brain area, release all kinds of mediators who are destroying the brain cells. Destruction of the brain cells and release of antigens results in antibody production against our own tissue. And this vicious cycle of autoimmunity continues because of that bad bacteria in the gut. So to summarize this part together, there are many factors: dietary proteins, antibodies, xenobiotics, physical stress, infections, some cytokines and neurotransmitters, enzymes, lack of digestive enzymes. All of that together can affect the gut integrity. When the gut integrity is broken, intestinal barrier dysfunction, food allergies, intolerance, immune abnormalities, and autoimmunities. So again, it's very important to prevent this and repair this as much as possible in your patients. So this is the test based on all the above. So I developed this test. First of all, I shared with you bacterial endotoxins was in that article, right? When the tight junctions break down, what will happen? These are proteins of our body. Our body will react against them and we make antibody. Which proteins are part of the tight junctions? Actomyosin, occludin, and zonulin. These are proteins of the tight junctions. When LPS and other factors break the tight junctions, we make antibody against them. So this is an example of a test we developed 5 years ago in comparison to lactulose mannitol, who, by the way, was developed almost 100 years ago. In the case of lactulose mannitol, which is a sugar, simple sugar, you give to your patients, what are you measuring? Permeability for a small molecule, which is a sugar. Permeability for a small molecule doesn't mean that you are measuring something that can challenge your immune system, resulting in antibody production first and then in autoimmunity. And so therefore, this is a new test so far. And in fact, I'm now working on a new version of this because I found out through literature there are other proteins of the tight junctions that we should measure antibody against them. For example, vinculin is another one. And there are more. So that's how a test gets developed in a laboratory. So now, back to a little bit statistic. This is real statistic that you will see that Parkinson's, Alzheimer's, stroke, 5 to 6 million, cancer, heart disease, diabetes, autism, ADD, ADHD, autoimmune, and finally allergies and asthma, especially this season right now. This is really bad. So that's the statistic. How can we improve upon all of that? By looking at environmental triggers. So I'm starting first with chemicals. That's my favorite part because I'm very chemical sensitive. Flying with very small airplane from LA to Santa Rosa, believe me, that was the smell of the fume coming inside, and I'm chemical sensitive. That wasn't fun. Okay? So here, more than 80,000 industrial chemicals registered. Only 5% have been tested. Ask yourself, how come the burden of proof should be on us and not on those which are producing the chemicals? How they allow chemicals into the product without being tested? But that's the reality. I don't want to get into politics part. 5% only being tested. And then 2,500 every year, new one, get introduced. And some of these chemicals are in 6 million different products that you and I may use every day. And some of these chemicals are metabolites. Our body, our liver metabolizes them. And then the metabolites can bind to our tissue and induce autoimmunity. Therefore, looking at how much chemicals being accumulated in our tissues is extremely important, and I will talk about that how. Not just measuring levels of chemicals in the blood, because believe me, all of us have chemicals in our blood and in our urine, between 700 to a few thousands of them. So, what is this?
Aluminum foil.
Okay, this is.
Oh, yeah, the plastic.
I think it was one of the airlines. I'm not going to mention their name. So they put this in 450 degrees, burning, right? They bring it to you, and you remove the aluminum, and you will see aluminum pieces are in the food. And today, in many scientific journals, including Mucosal Immunology, that those which you are clinicians, maybe you don't read even that journal. You don't know even about that journal. But I'm an immunologist, I read that. An article came last year in this journal called Mucosal Immunology. So far, they have shown that aluminum gets about 20% into the muscle. Another 20–30% goes into the brain. That's why relationship between Alzheimer's and aluminum. But now in this article show that 40% goes into the epithelial cells of your gut. Isn't that causing gut dysbiosis? So that's just one example. So therefore, I have many other slides about this, just to let you know that sometimes we do things every day without paying attention to them. But we are entering more chemicals, letting more chemicals to get in our body. What is the title of this article? And Chemical Research Toxicology. Dr. Pollard is part of the Immunology Department of Scripps Research Institute in San Diego, one of the best research centers also in the world. He's talking about toxicology of autoimmune disease. That's exactly what I'm talking about tonight. Chemicals can cause autoimmune disease. I'm not going to read all of that for you guys. Just get the message. That's why the test was developed by me a few years ago. Actually, it started in 1988 when we had residents of mobile home in Los Angeles area in Malibu, which we tested them for formaldehyde antibody. And they had very high levels of formaldehyde antibody. So when you live in an environment that formaldehyde off-gassing every day, whether it's from carpet or, in this case, mobile home, formaldehyde gets to your system, binds to your tissue, you make antibody against formaldehyde as well as your own tissue, which we call it body burden of chemicals. So by looking at aflatoxin, you should pay attention to that. It's everywhere in food. Aflatoxin binds to food, aflatoxin binds to our DNA, to our RNA, and that's one mechanism of autoimmunity. Other chemicals, isocyanate, trimethylene anhydride, plasticizers, benzene ring, also bisphenol A, plastic. Believe me, I never drink. This is maybe my second time I'm drinking water from plastic bottle. So please do not tell your patients not to drink in plastic bottles. There is no such thing as bisphenol A free. 10 years from now, we'll tell you that BPA free is as bad as bisphenol A. So plastic is plastic. And tetrabromobisphenol A, fire retardant, and parabens, cosmetics, ladies, I don't dare even to talk about it in front of my wives and my daughters, because ladies are very sensitive about this. You cannot criticize them. But they put poison really on their skin, on hair, and everything. So I don't want to be the bad guy, but I already said it, you guys get the message. So parabens, mercury compounds and heavy metals are everywhere, okay? So those are, so what we did, the question I was asking in this article, which was published in Journal of Applied Toxicology, it's one of the good scientific journals in the field. What percentage of healthy population make antibodies against those chemicals and their own tissue simultaneously? These are healthy subjects, so-called. And so the answer was between somewhere 10 to 17%, depends what kind of antibody you look at. And this is the comments of the referees when they accepted my article for publication. By saying that the study is very interesting, timely, and relevant, finding reported here have the potential to challenge the status quo. What is the status quo? The status quo is, if you want to look at exposure to chemicals, you measure chemicals in the urine and the blood. But we have it. All of us, we have it. Why do we need to waste our money? But when you measure antibodies against chemicals bound to your tissue, that's a reflection of your lifetime exposure to chemicals. And that's exactly what they're saying. So the role of environmental contaminants in autoimmunity. And by the way, if you need this article, I'll be very happy to send several copies to Dr. Ambridge, or you can go just online. These are, you can just download them under Vojdani. So let's summarize the part of the chemicals, and then we'll get to the diet and then to the infection. So chemical exposure depends on genetic factors and barrier breakdown. So I'm connecting now chemical exposure to barrier breakdown. Now chemicals or their metabolites, oxidative stress, formation of neoantigen. What is neoantigen? Meaning our own tissue, when it's attacked by chemicals, form new antigen, which our immune system is going to recognize as a foreign material and attack it. That's a mechanism of autoimmunity. And then activation of macrophages, immune system, attacking that, antibody, pro-inflammatory cytokines, inflammation, autoimmune reactivities. First autoimmune reactivities, by the way, antibodies are detected in the blood 10 years before the onset of autoimmunities. So first antibodies, then what is the message? You can reverse. You can treat your patient at the level of antibodies, and 10 years later, that patient is not going to end up with autoimmune disease. Again, let's look at the title together. Pesticides Report, Bound Xenobiotic Residues in Food Commodities of Plants and Animal Origin. What is the meaning of these bound xenobiotic residues? to food, proteins, and then to our own tissue. So instead of reading that for you guys, here, example. We call this body burden of chemicals, right? Chemicals eventually get to our body, accumulate, some of them get metabolized, cleared through the urine, but the rest stays in our tissue. So here, organophosphates from air, soil, underground water, and other water bodies, fish, and all together, that chemicals get into the meat, dairy, and fish. Finally, we are the last level of accumulation, absorbing all those chemicals into our tissue. This is mainly responsible for the development of autoimmune disease. So body burden of chemicals. So measuring of chemicals in the blood and urine is not good enough. So I finished with the issue of chemicals, okay? So far, now let's go one step. Further talking about the role of dietary proteins and peptides and dietary components, very short, in autoimmunity. Okay, so I start with this Mr. Peanuts, right? You see the commercials all the time, every night. So 63% protein, that's fantastic. Fat 22%, which is a good fat. Fiber 10%. But the problem is whether that peanut has the other 5% or not. Aflatoxin, pesticide, herbicide, and heavy metals. So let's go to the next. And these are, by the way, amino acids of the proteins of peanuts. If this is pure peanut protein, and you have good digestive enzymes, what is the role of digestive enzymes? To digest proteins to small peptides, that's a peptide, and then to amino acids. The amino acids get absorbed, and that's fuel for our body. Now let's, for the sake of argument, one peptide even is not digested entirely out of all these proteins. What will happen? Remember the T-Rex cell? The cell playing a role in changing the balance? That's the cell. Releases TGF-beta and IL-10, these are cytokines, can block immune response against that single peptide. And therefore, no harm is done. The immune system is not going to react against that, and no immune reactivity and no autoimmunity. But now, let's go to the next step. What will happen if those toxins, aflatoxins, and others are bound to different amino acids of the protein of the peanuts? What will happen? The digestive enzyme works to a certain level, cannot digest everything. And therefore, now we have so many undigested peptides which cause inflammation in the gut. From there, they go to the submucosa, antigen presentation, B cells produce antibodies, and that can result in food immune reactivity. So peanut here is just one example. That can happen with corn or any other food as well. And by the way, for those who have this special issue, I'll talk about it. There are 7 manuscripts actually talking about all kind of, all these issues. So if you want to read about, right here. So what do we learn from this? First of all, organic diet is important. Secondly, digestive enzymes are important. And that's why, don't be surprised when you go to a clinician and will tell you, you should take some digestive enzymes. That's a blessing for our digestive tract. Listen to that. That's the mechanism. That's why I came up with this. We were at A4M. You know, this is Cyrex actually. They were promoting food immune activity, and they were offering us wine, so I had to match the picture. So food immune reactivity and autoimmunity. What is the relationship between food and autoimmunity? And everything is right here. You have to read this. History from 1986, when I developed food IgG testing, until today, until a year ago. So what? You heard a lot about wheat proteins. Wheat has many, many proteins. By the way, some of them are in the new wheat, which were not in the old wheat. And from laboratory point of view, there are some articles which prove that that's the case. There are new peptides in the new wheat, which they were not there before. That's